Okay, here we are in 6.4, talking about applications of linear systems. So this should be the title at the top of your notes. 6.4, applications of linear systems. So our goal here is to choose the best method for solving a system of linear equations, because we've talked about graphing, we've talked about substitution, we've talked about elimination, and now we want to practice solving problems and deciding which is the most efficient method to use. So let's look at a little concept summary of choosing a method for solving linear systems. So we have graphing, and when we want to use it is when you want a visual display of the equations or when you want to estimate a solution, right? Because if we have a graph and then we have two lines on the graph, where they intersect, so that point in there, that is the solution, right, where they intersect. So if we're dealing with some sort of data or a situation where we want to see that intersection or estimate that, then graphing would be a good method, right? But it's not exact as substitution and elimination. So substitution, when one equation is already solved for one of the variables, or when it is easy to solve for one of the variables, would be situations when we want to use substitution, right? If we have x plus y equals 3 and 3x minus 4y equals 7, right? Those are great options for substitution because we can make that x equals 3 minus y and then substitute that in for this x. And third, elimination, when the coefficients of one variable are the same or opposites, or when it is not convenient to use graphing or substitution. So elimination can be your last option if you want it to be. Some people don't like it as much as substitution or and this, maybe if you think, oh, substitution would be a little bit complicated here, then opt for elimination. Okay, we're going to look at this first problem on here. I'm trying a little different of a video. So it says you have $6,000 to invest in 2 stock funds. So it tells you 2 stock funds right there, okay? So we know that our X and Y's are probably going to have to relate to those stock funds. So the first fund pays 5% annual interest and the second account pays 9% annual interest. If after a year you have made $380 in interest, how much money did you invest in each account? So let's think about it. Our total amount that we invested was $6,000, right? Because it said that you have $6,000 to invest in 2 stock funds. So my X is going to be amount invested in, let's say, the 5% stock fund, so the fund that pays 5% interest annually. And then my Y is going to be the amount out of the 6,000 invested in the 9% fund, the fund that pays 9% of annual interest. Okay, so the total amount I had was $6,000, right, that I'm investing. So the amount I invest in one plus the amount I invest in the other is going to equal 6,000. So there's one equation, right? And then it says, if after a year you have made $380 in interest. So to figure out how much interest I made off of this one, where I invested X dollars, well, to find the percent of a whole number, right, I just changed that 5% to 0.05 times the amount I invest. That's going to give me my interest, right? Plus 0.09 times Y, right? Because if I invested 9%, I change that to a decimal and multiply it by the amount, and that tells me 9% of it. And that equals $380. So now I have my 2 equations and 2 unknowns. I've defined my variables, right? So on a test, that's the majority of your points right there. So now both these variables are by themselves. So I can solve this, let's say, for x. So x equals 6,000 minus y. And now I can substitute that value for x right here. So I get 0.05 times 6,000 minus y plus 0.09y equals 380. And you multiply all that, and you're going to get what? What is that? That gives me 300 minus 0.05y plus 0.09y equals 380. Minus 300 minus 300, that goes away. I'm left with 80 on that side. And negative 0.05 plus 0.09 is 0.04y. Divide by 0.04, divide by 0.04. And I get y equals 2,000. So what does that tell me? Well, let's look back up here. What is y? It's the amount invested in the 9% stock fund. So at that point, if he invested a total of $6,000, and I know he invested $2,000 in the 9% fund, how much did he invest in the 5% fund? Well, 6,000 minus 2,000, right, equals 4,000. So that's going to equal x. So there are your answers. So again, when you get confused, look back at the question. It says, how much money did you invest in each account? So that tells you you need to have both your x and your y. You have to have them defined so that I know which one is which account, how much money is with which account. Okay? So that's just one more example of a word problem, defining variables, writing equations, and then solving for the variables using substitution. Okay, now we're going to look at an example when elimination might be the easiest method rather than substitution. Because if we look at this problem here, we have a negative y in each equation, right? So we could easily change this, multiply this whole equation by -1. So let's just rewrite these over here. So we get 2x minus y equals 4. And -1 times 3x, we get -3x. -1 times -y plus y. -1 times 2, -2. And now we combine these together, right? You add them, you subtract them. In this case, we're subtracting it, right? Because we're multiplying this by -1. But I think of it as just combining them. So we have a 2 and a -3, so that gives me -1x. Y and y, those cancel out. And 4 and -2, that gives us a +2. X can't be negative, so if we divide this by -1, we get x equals -2. Right? So that was fairly easy. So we could take this -2 and substitute it back in to either equation. I'll put it back into that one. So I get 2 times -2 minus y equals 4. So we get -4 minus y equals 4, plus 4, plus 4, y equals 8, divided by -1, and you get y equals -8. So my solution is -2, -8. So that was an example when elimination is a pretty easy option for solving for the solution to this system. But again, you could have used substitution as well. This is just, it's kind of your choice, what you're most comfortable with, and what you think the path of least resistance is to solving this problem.